What we have here is two vertical poles, A and B, of height h, are standing on opposite sides of a level road. They are 24 metres apart in total. The point P on the road directly between the two poles is a distance x from the pole A. The angle of elevation from P to top of pole A is 60 degrees. Write h in terms of x. Now h in terms of x, where is the h located and where is the x located? It's located in this triangle here. H is the opposite, x is the adjacent. So it makes sense for us to use tan. So tan 60 equals h over x. What is tan 60 in the calculator? Pretty sure it's root 3. Is everybody happy with that? Root 3 equals h over x. Now, it wants h on its own. Bring the x up, and you're going to get root 3x equals h. Happy enough with that? Okay? Any questions? Okay. From P, the angle of elevation to the top of pole is 30 degrees. Find h in terms. Find h, the height of the two poles. Okay, now this is interesting. This triangle here, okay, which I'm going to colour in green right now. Now, this one here, okay? What I'm going to do is I'm going to find out what tan 30 is. Now, what length is it from here to here, in between the two black dots? Can anybody tell me? What is it? 24 minus x. It's 24 from here all the way to here, but your x of it is dedicated to the red part, so it's 24 minus x. Tan 30 ends up to be h over the square root of 24 minus x. Now, we're going to use the answer of part 1. What did we say x was again? What did we say h was? H is root 3x. What's tan 30? Can anybody tell me? Tan 30? Sorry? It's 1 over root 3, which is also root 3 over 3. They're the same thing, but let's go with what the calculator has, okay? And what's this one here? This here is going to be root 3x over 24 minus x. Now guys, what can we do with the root 3's? If root 3 is being multiplied on the right and the left, we can cancel them off and make them 1 each. Cross multiply. 24 minus x equals, anybody? 3 times x. Move x over the other side. 24 equals 4x. X therefore must be 6. Yeah? And what do we say h is equal to again? Root 3x. H therefore must be 6 root 3. So guys, this is theorem 14. Oh sorry, theorem 19. Okay? So what you're going to have to do is you're going to have to draw your own construction. There's your circle. Okay? And what you're going to do is have a triangle, or 3 sides A, B and C. So it doesn't matter what way you label them. I'll just keep it the same as the book for the time being. CAB. Now you're going to need the centre of the circle, which is located here. That's O. And then we're going to join here to here and here to here. Okay? Now that's the start. Now it asks you what you're given. Okay? So what we're given is a circle K. I'll write up here. Circle K. We'll call this. You can make up any letter you want. Circle L, circle M, centre O. Okay. ABC are 3 points on A. Oh, sorry, 3 points on K. Alright. And the angle AOB, does everybody see the angle AOB? this angle here. The angle AOB is the angle at the center of the circle. Okay? So angle AOB is at the center. And then the other angle, which is ACB. Angle ACB is at the circumference. Now, there's one other thing you gotta do. What arc do they both stand on? Do you know what I mean by an arc? Where does the angle start and finish? A, C, B. It starts at A, ends at B. A, O, B. Starts at A, ends at B. What arc do they both stand on? What's the name of this arc? Both stand on the arc A, B. This is on page 335 if you're wondering where I'm getting it from. Okay? Both stand on the arc. Both stands on the arc AB, I mean. Now, what are you looking to prove? You're looking to prove that the green angle is twice as big as the blue angle. To prove angle AOB, okay, equals twice the angle ACB. The two lines means the value, like as in degrees, okay? Construction. What are we doing next? Join. Now, what we're going to have is, we're going to join C to O and continue to D. So, we're doing this. We're going to continue down to D. Okay? Alright, we're going to label the angles. So, what we're going to do is just label all the angles, okay? So, angle 5, 3, once again, doesn't matter what way you label them. 1, 2, 4, and 6. Okay? Now, what we got to do is we got to prove that angle 1 plus angle 2 is 2 times what? Angle 3 plus angle 4. Do you understand where I got that from? Angle AOB is angle 1 plus angle 2. Angle ACB is angle 3 plus angle 4. So let's begin. Okay? So let's start off. This one here is the same length as what? What can you say about these two? What can we say about these lengths? They're all equal. So, triangle AOC and triangle COB are what, guys? What's that word? Are isosceles. Okay? So, they're isosceles. Okay? Now, there's something that's called the exterior angle in triangles, and let me show you an example. If I draw a straight line, and on this straight line, I then draw a triangle, like so. Okay? Now, if I say this angle here is, let me see, 50 degrees. Okay? This one up here can be not 80, we'll go 70. And this one up here is 60. What can you tell me about this angle here? What? This angle here is 130. And you see this angle here? It always equals the other two angles added together. So if you weren't given that 50, you could do it right away. You could just say, oh, that angle equals these two added together, which is 130. Do you understand? Do you know what this is called? Exterior angle. Okay? Exterior angle. Okay? So, what we're going to get next is this, guys, okay? We're going to now write down our exterior angles. Which angle is exterior to this triangle here to the left? What's the exterior angle? Number 1. Number 1 equals angle 5 plus angle 3. Angle 1 equals angle 5 plus angle 3. Reason being, exterior angle. Okay? Okay. So one sec, guys. So, okay. So there we go. Next one, okay. Look at this one here. Angle 2, which is outside the triangle, must equal what, Robert? Angle 2 has to equal angle 4 plus angle 6. The angle that's outside the triangle in the straight angle has to equal the other two added together on the inside. I'm going to stop now for a second. Any questions? Alright. So, what happens next is this angle 2 has to equal angle 4 plus angle 6. Now, the next thing we got to write down, and we can do this to the side, we're looking to use angle 3 and angle 4 only. Do you understand? Angle 3 and angle 4 only. So, angle 5 equals angle 3. Can anybody tell me why angle 5 equals angle 3? Isosceles triangle. And why does angle 6 equal angle 4? Can anybody tell me? Isosceles triangle. Now what does that mean for both of them, guys? It means that angle 1 now equals angle 3 plus angle 3, which is 2 times angle 3. You got it? 2 times angle 3. And what about angle 2? It's now going to equal angle 4 plus angle 4, which is 2 times angle 4. Now, this now means angle 1 plus angle 2 equals 2 times angle 3 plus 2 times angle 4. What's the name of angle 1 plus angle 2? AOB. Angle AOB must equal, now this is 2 times angle 3 plus angle 4. What's angle 3 plus angle 4 called? Angle 3 plus angle 4? ACB. And is that what we're asked to prove? And we can put them in lines, okay? Proven. 15, okay? Prove that the angle x plus y plus z equals 360. This is what I was discussing with you earlier on about the exterior angle, okay? Once again, if I have a triangle, I have a line, and I said that this one here is 50 and 80. It means the angle on the outside has to be 130. Now, the problem here is we're given absolutely no numbers, okay? The only number we can be dead certain of is what, guys? That the 3 inner angles add up to what? Angle 1, angle 2 and angle 3 have to add up to 180. So look, angle 1 plus angle 2 plus angle 3 has to add up to 180 degrees. Now look at this. Angle Z is equal to what, guys? Angle Z is equal to what two angles added together? Remember we did it a second ago? The exterior angle? It's equal to angle 2 plus angle 3. I'm going to make my Z with a, just make it look different than my 2. Angle 2 plus angle 3. What about angle X, guys? Angle X is angle 1 plus angle 3. And what about angle Y? Angle Y is going to be angle 1 plus angle 2. Now, what it says in the question is to add them all together. X plus Y plus Z. And what we're going to get is angle 1 plus angle 3 plus angle 1 plus angle 2 plus angle 2 plus angle 3. Now look what happens here. It's going to be 2 times angle 1 plus angle 2 plus angle 3, because we have 2 angle 1s, 2 angle 2s and 2 angle 3s. And what do we say angle 1 plus angle 2 plus angle 3 is? 180. 2 times 180 gets me 360 degrees. And that's approved. Okay? Now, finally, the diagram below shows a parallelogram and one exterior angle. Find the value of A and the value of B. Okay? So the value of A and the value of B. Now guys, there's a rule about parallelograms. Does anybody know the rule about parallelograms? Opposite angles have to be the same. Do you understand? And this one here has to be equal to this one here. Now, with this in mind, what do you think this one here is? What do you think this angle here has to be? 30 degrees. This means that 3A equals 30 degrees. It means A equals 10. Now we know there's two 30s. What angle does this one here have to be in terms of B? It's also going to be 5B. Do you understand? Now, in any four-sided object, all four angles added together must equal 360 degrees. So 30 degrees plus 5B plus another 30 degrees plus 5B must equal 360 degrees. Then 60 degrees plus 10B equals 360. Bring the 60 over the other side, becomes a minus 60. 10B equals 300. B therefore must be 30. Okay? 30 degrees. Is that the last?